Hi students, in this video we are going to see about integration testing. A strategy for software testing may also be viewed in the context of the spiral. Unit testing begins at the vertex of the spiral and concentrates on each unit of the software as implemented in source code. Testing process by moving outward along the spiral to integration testing, where the focus is on design and the construction of the software architecture. Taking another turn outward on the spiral, you encounter validation testing, whose requirement established as a part of requirement modeling or validated against the software that has been constructed. Finally, you arrive at system testing, where the software and other system elements are tested as a whole. To test computer software, you spiral out in a clockwise direction along streamlines that broaden the scope of testing with each turn. Considering the process from procedural point of view, testing within the context of software engineering is actually a series of 4 steps that are implemented sequentially. Initially, tests focus on each component individually, ensuring that it functions properly as a unit. Hence, the name unit testing is discussed in previous videos. Unit testing makes heavy use of testing technique that exercise specific path in components control structure to ensure complete coverage and maximum error reduction. It is also discussed as black box testing and white box testing in our previous videos. Next, component must be assembled or integrated to form the complete software package. Integration testing addresses the issues associated with the dual problems of verification and program construction. Test case design techniques that focus on inputs and output are most prevalent during integration, although techniques that exercise specific program path may be used to ensure coverage of major control paths is explained in this video. A neophyte in the software world might ask a seemingly legitimate question. Once all the modules have been unit tested, if they all work individually, why do you doubt they will work when we put them together? The problem, of course, is putting them together, interfacing. Data can lost across an interface. One component can have an adverse effect on another. Subfunctions, when combined, may not produce a desired major function. Individually, acceptable imprecision may be magnified to unacceptable levels. Global structures can present problems. Sadly, the list goes on and on. Integration testing is a systematic technique for constructing the software architecture while at the same time conducting tests to uncover errors associated with interfacing. The objective is to take unit tested component and build a program structure that has been dictated by design. This is often tendency to attempt non-incremental integration, that is, to construct the program using a Big Bang approach. All components are combined in advance. The entire program is tested as a whole and chaos usually result. A set of error is encountered. Correction is difficult because isolation of cause is complicated by the vast expansion of the entire program. Once these errors are corrected, new ones appear and the process continues in a seemingly endless loop. Incremental integration is antithesis of a Big Bang approach. The program is constructed and tested in a small increments where errors are easier to isolate and correct. Interfaces are more likely to be tested completely and a systematic test may be applied. Let us understand the concept with the example. System or software application consists of following modules. Each modules M1, M2, M3 are tested individually as a part of unit testing. Modules are combined incrementally, that is, one by one, and tested for successful integration. Module 1 and Module 2 are combined and tested. Module M3 is added and tested. Module M4 is added and testing is done to make sure everything works together successfully. Rest of the modules are also added incrementally at each step and tested for successful integration. A number of different incremental integration strategies are discussed. Top-down integration testing is an incremental approach to constructions of the software architectures. Modules are integrated by moving downward through the control hierarchy. beginning with the main control module. Modules subordinate to the main control modules are incorporated into the structure in either a depth-first or breadth-first manner. Depth-first integration integrates all components on a major control path of the program structure. Selection of major path is somewhat arbitrary and depends on application-specific characteristics. For example, selecting the left-hand path, components M1, M2, M would be integrated first. Next, M8 or M6 would be integrated. Then the central and right control paths are built. Breadth-first integration incorporates all components directly at each level, moving across the structure horizontally. From the figure, component M2, M3, M4 would be integrated first. The next control level M5, M6 and so on follows. The integration process is performed in a series of 5 steps. The main control module is used as a test driver and steps are substituted for all components directly subordinated to main control module. Depending on the integration approach selected, that is depth or breadth first, subordinate steps are replaced one at a time with the actual components. Tests are conducted as each component is integrated. On completion of each set of tests, another step is replaced with the real component. Regression testing may be conducted to ensure the new errors have not been introduced, which we will discuss at the end of the video. The top-down integration strategy verifies major control or decision point early in the test process. In a well-factored program structure, decision making occurs at the upper level in the hierarchy and it is therefore encountered first. Top-down strategy sound relatively uncomplicated, but in practice, logistical problems can arise. The most common of these problems occurs when processing at low level in the hierarchy is required to adequately test upper level. Step replace low level modules at the beginning of top-down testing. Therefore, no significant data can flow upward in the program structure. Another approach called bottom-up approach. Bottom-up integration testing, as its name implies, begin construction and testing with the atomic modules, that is, component at the lowest level in the program structure. Because components are integrated from the bottom up, the functionality provided by components subordinate to a given level is always available and the need for stub is eliminated. A bottom-up integration strategy may be implemented with the following steps. Low-level components are combined into clusters, sometimes called builds, that perform a specific software subfunction. A driver control program for testing is written to coordinate test case input and output. The cluster is tested, drivers are removed and clusters are combined, moving upward in the program structure. Each time a new module is added as a part of integration testing, the software changes. New data flow paths are established, new I/O may occur and new control logic is invoked. These changes may cause problem with the function that previously worked flawlessly. In the context of integration test strategy, regression testing is the re-execution of some subset of tests that have already been conducted to ensure that changes have not propagated unintended side effects. Successful test of any kind results in the discovery of errors and errors must be corrected. Whenever software is corrected, some aspect of software configuration program, its documentation or data that support it is changed. Regression testing helps to ensure that changes do not introduce unintended behavior or additional errors. The regression test should contain 3 different classes of tests. A representative sample of tests that will exercise all software function, additional tests that focus on software function that are likely to be affected by the change, tests that focus on the software component that have been changed. As integration testing proceeds, the number of regression tests can grow quite large. Therefore, the regression test suite should be designed to include only those tests that address one or more classes of error in each of the major program function. It is impractical and inefficient to re-execute every test for every program function once a change has occurred. Thank you.